Hello student, good morning. Today I am going to discuss some important compounds of transition elements. In that I am going to discuss potassium dichromate K2Cr2O7. Potassium dichromate. Potassium dichromate is a very important chemical used in leather industry and as an oxidant for preparation of many azo compounds. Dichromates are generally prepared from chromate, which in turn are obtained by fusion of chromite ore. Chromite ore means FeCr2O4 with sodium or potassium carbonate in free access of air. The reaction with sodium carbonate occurs as follows. FeCr2O4 plus Na2CO3 plus oxygen. Balanced reaction I am telling you. 4FeCr2O4 means chromite ore. 4FeCr2O4 plus 8Na2CO3 plus 7O2. It gives three products. First, 8Na2CrO4 sodium chromate plus 2Fe2O3 ferric oxide plus 8CO2 carbon dioxide. The yellow solution of sodium chromate, actually 8Na2CrO4, this is sodium chromate, its color is yellow. The yellow solution of sodium chromate is filtered and acidified with sulfuric acid to give a solution from which orange sodium dichromate means Na2Cr2O7 2H2O can be crystallized out. Orange sodium dichromate. Okay, sodium dichromate's color is orange. Then from Na2CrO4, it gives Na2Cr2O7. You will get Na2Cr2O7 from Na2CrO4. Then 2Na2CrO4 plus 2H plus means acidic medium. 2Na2CrO4 plus 2H plus. It gives Na2CrO7 plus 2Na plus H2O. This, how will you get sodium chromate? I told you. Now how this from this sodium dichromate Na2Cr2O7, this is sodium dichromate. Now you want potassium dichromate. Then how you will get? Then it is very easy. Sodium dichromate is more soluble. Sodium dichromate is more soluble than potassium dichromate. The latter is therefore prepared by treating the solution of sodium dichromate with potassium chloride. Means sodium Na2Cr2O7 plus 2KCl. Then now we will get K2Cr2O7 plus 2NaCl. Very easy. Na2Cr2O7 plus 2KCl. It will give K2Cr2O7 plus 2NaCl. Orange crystal of potassium dichromate crystallize out. Now you got potassium dichromate plus 2NaCl. Then now this potassium dichromate, its color is orange. Orange crystals of potassium dichromate crystallize out. The chromates and dichromates, there are two. Chromates and dichromates. if only one chromium is there, then it is chromate, means KCrO4. Okay, then these things, as for example, Na2CrO4, this is the chromate, sodium chromate, Na2CrO4, only one chromium is there, Na2CrO4. But in potassium dichromate, there are two chromium, K2Cr2O7 plus NaCl. Then I told you that how will you get potassium dichromate from this sodium chromate, Na2CrO4. Then Na2CrO4 plus acid medium, means plus 2H. Then you will get a sodium chromate. From monochromate you got dichromate, and from the dichromate, from sodium dichromate, with treatment with KCl, you got K2Cr2O7, potassium dichromate plus NaCl. Then K2Cr2O7, its color is orange. Now the chromate and dichromate are interconvertible in aqueous solution depending upon pH of the solution. The oxidation state of chromium in chromate and dichromate is the same. This you should understand. Okay, the oxidation state of chromium in chromate and dichromate is the same. Reaction you see, 2CrO4 2 minus, 2CrO4 2 minus plus 2H plus, means acidic medium. You got, or you will get Cr2O7 2 minus plus H2O. And second reaction, Cr2O7 2 minus, means dichromate ion, plus basic medium 2OH minus, 2OH minus, you will get 2CrO4 2 minus plus H2O. Means from the chromate you got dichromate, and from the dichromate you got chromate, interconvertible. Correct? From the chromate CrO4 2 minus, in acidic medium you will get Cr2O7 plus H2O, Cr2O7 2 minus, that is the dichromate ion. And from the dichromate ion in basic medium, means Cr2O7 2 minus plus 2OH minus, you will get chromate ion, 2CrO4 2 minus plus H2O, means both are interconvertible. If chromate is there, then in acidic medium it will give dichromate, and dichromate in basic medium it will give chromate. And here you can see oxidation state. In chromate, what is the oxidation state? Then CrO4 2 minus, means Cr minus 8, means 4 into minus 2, minus 8, that is equal to minus 2. Okay, 2 minus is there. Then now what will the value of Cr? Then this minus 8 will go right side, then it will become plus 8 minus 2, means plus 6. It means in CrO4 chromium has plus 6, and in Cr2O7 2 minus, then Cr2 means 2Cr plus, you can write 7 oxygens are there, 7 into minus 2, minus 14, then 2Cr minus 14 is equal to minus 2, then 2Cr is equal to minus 14, minus will be converted to, minus will become 14, take it to the right hand side, then 2 Cr is equal to plus 14 minus 2 means plus 12. Then 2Cr is equal to plus 12. Then Cr is equal to plus 6. Then in both, in chromate and dichromate, chromium has plus 6 oxidation state. Plus 6 oxidation state means same. The structure of chromate ion and dichromate ion I will tell now. It is very easy. Chromate ion structure I am telling you. The chromate ion is tetrahedral. The chromate ion is tetrahedral, whereas the dichromate ion consists of two tetrahedral or two tetrahedra sharing one corner with CRO-CR bond. CRO-CR bond angle is 126 degree. In dichromate, CRO-CR, this bond angle is 126. Now, little more I am telling you about the chromate ion. In the middle, chromium will be there and 4 oxygens are there. Then here all four oxygens are joined with one chromium in the middle and 4 oxygens are there. Then all 4 oxygens are joined with chromium with single bond. Then 3 are down, 1 is up. Okay, just like a tetrahedral structure. One bond is CRO, one single bond is upside, and 3 are down. And just like a tetrahedral structure. And this structure you can write in bracket, and out of bracket you write 2 minus. This is the chromate ion having 2 negative charge. Now dichromate ion. Then dichromate ion, again it is similar to chromate ion, but here 2 chromate ion you have to use, and both chromate ion are linked with oxygen. Okay, in the middle oxygen will be there, and from this oxygen one left side, other right side, chromate ion is linked. Means Cr, 3 oxygens are down and 1 oxygen is above, up. Then it became 4. Then this oxygen is common in both. Again second chromate is there, then 3 oxygen is down. 3 oxygen is down and one oxygen is above. Then this above oxygen is common in both CrO3, and fourth one oxygen that is in the middle, and it is forming an angle CrO-Cr. Oxygen in the middle, CrO-Cr. Its bond angle is 126. And chromium and oxygen bond, single bond, which is in the common for both chromium. Then its bond length is 179. Cr and O. Okay, CrO-Cr. That CrO bond length is 129 picometer. And other CrO bond, left side 3 oxygens are there, right side 3 oxygens are there, and all are joined with chromium. Left side chromium 3 oxygen, right side can say chromium is linked with 3 oxygen. Correct? Right side and left side, both side chromium are there, and from each chromium 3 oxygens are joined with single electron. Then this CrO bond, its bond length is 163, less than common oxygen, Cr and O, common oxygen, that is 179 picometer. Then 179 picometer bond length is more, means this bond is big or bigger than other bonds, other CRO bonds. CRO bond is 163. 3 plus 3, 3, 6 CRO bonds are there, including both chromium. Then all are 163 picometer, which is stronger than CRO bond. This is 129. Sodium and potassium, this I told you about the dichromate. That's why name has given dichromate, because two chromium was there and both chromium is joined through oxygen, having 126-degree angle. This is the structure of dichromate ion, and in bracket, big bracket, this structure you can write, and outside 2 negative. Just like chromate ion 2 negative, dichromate ion also have 2 negative. Now I am telling ahead. Sodium and potassium dichromate are a strong oxidizing agent. This is very, very important. The sodium salt has a greater solubility in water. Sodium salt dissolves more in water and is extensively used as an oxidizing agent. It is generally used as an oxidizing agent in organic chemistry. Now come to the potassium dichromate. Potassium dichromate is used as a primary standard volumetric. It is used in a volumetric analysis as a primary standard. As a primary standard solution, potassium dichromate is used in volumetric analysis. In acidic solution, its oxidizing action you can understand like that. I am telling you, Cr2O7. In acidic medium I am talking about. In acidic medium, potassium dichromate or sodium dichromate, anyone. That's why I am telling you Cr2O7 2 minus. Plus 14H means acid medium. H plus means acid medium. It is balanced equation. Cr2O7 2 minus plus 14H plus 6 electron. It will give 2Cr3 plus 7H2O, and it will create potential how much? 1.33 volt. This is actually half reaction. In electrolysis, this is actually a reduction reaction. Plus 6E, 6 electron, it is adding. Okay, then this is the example of half reaction, reduction reaction. Cr2O7 2 minus plus 14H plus 6 electron. It gives 2Cr3 plus 7H2O, and reduction potential value is 1.33 volt. And here you can see Cr2O7 2 minus, here chromium is plus 6 oxidation state, but as a product it is giving chromium 3 plus means that plus 6 now converted to plus 3 by taking electron. Thus acidified potassium dichromate will oxidize to iodine. Okay, this acidified potassium dichromate will oxidize iodides to iodine. This is a very, very important role of potassium dichromate. Acidified potassium dichromate, what it will do? Then it will oxidize iodides to iodine, and sulfides to sulfur, and tin second to tin fourth, and iron second salt to iron third. 4 reaction I have told you, where potassium dichromate will be used as oxidizing agent. It oxidizes first iodide to iodine first, second sulfides to sulfur, sulfide to sulfur, third tin second to tin fourth, and fourth one iron second to iron third. Okay, you know that in oxidation what will happen, that you know, loss of electron. Then that electron who will take? Then oxidizing agent will take that electron. Okay, now example I am telling you, iodide ion is converting to iodine in presence of potassium dichromate. Then 6I minus, it is giving 3I2 plus 6 electron. Now you can see iodide ion was having -1 oxidation state. Now it became I2. 3I2 means I2 is 0 oxidation state. Then I minus 1, it lost 1 electron. And now 6I converted to 3I2 means I2 is 0 oxidation state, plus it released 6 electron. 6I, now it converted to 3I2 plus 6 electron. And now second reaction I am telling you, H2S is converting, means sulfide. H2S means what? H2S means sulfur is sulfide. Yes, 2 minus you can tell. H2S. Then 2H is there, obviously 2H. 2H is plus, H plus, H plus. It means S is 2 minus. Then H2S converts to 6H plus 3S plus 6 electron. Means balanced equation I am telling you, 3H2S. 3H2S converts to, it gives 3 products, 6H plus 3S plus 6 electron. Then now you can see S in H2S, S is -2. Now it converted to sulfur. Sulfur is 0 oxidation state. Means in H2S, S was having -2. Now it became 0. S became 0. Right side means product, it became S0. 3S means S is 0. Means here it lost the electron. Then 1S, 1H2S will lose 2 electrons. Then 3H2S, 6 electron. That's why balanced equation 3H2S plus 3H2S gives 3 product, 6H plus 3S plus 6 electron. Now third reaction you can see, SN2 plus, now it is giving SN4, 4 plus. All reactions are taking place in the presence of potassium dichromate. Don't forget. Then 3SN2 plus, it is converting 3SN4 plus 6 electron. Now come to the fourth reaction. Fe2 plus converts to Fe3 plus in presence of potassium dichromate. Means 6 Fe2 plus, it gives 6 Fe3 plus 6 electron. Okay, these are the examples of these are the examples of, you can say, potassium dichromate functioning as oxidizing agent. Okay, only in the presence of potassium dichromate all these reaction takes place. Correct? And it converts iodides to iodine, sulfide to sulfur, tin second to tin fourth, and iron second to iron third. And now it is the half reaction. All are half reaction. Wherever electrons are there in the product, that means that is the half reaction. Correct? Then if you want to write the full reaction, then what you have to do? The full ionic equation may be obtained by adding another half reaction for potassium dichromate to the half reaction for reducing agent. Okay, this is the oxidizing agent. What I told you, 4 reaction, that is oxidizing reaction. Okay, now you want full reaction, then reducing reaction, you half reaction for a reducing agent you have to write and then add it. Then oxidation reaction and reduction reaction, if you will add, then you will get full reaction. Okay, half is the oxidation reaction, another half will be the reduction reaction. Then oxidation reaction plus reduction reaction is equal to full reaction, redox reaction. Okay, then full ionic equation may be obtained by adding the half reaction for potassium dichromate to the half reaction for the reducing agent. Okay, then finally you will get reaction. I am telling you, Cr2O7 2 minus plus 14H plus 6Fe plus 6Fe 2 plus, and you will get final product 2Cr3 plus 6Fe3 plus 7H2O. Okay, I have told first, actually already I discussed first, see that this reduction reaction on the beginning I have discussed. Cr2O7 2 minus plus 14H plus 6 electron, it gives 2Cr3 plus 7H2O. This is a reduction reaction and E value is 1.33 volt. In this reaction you have to add iron reaction as for example. Then 6Fe2 plus is giving 6Fe3 plus 6 electron. You add it, then electron will be cancelled out and it will remain. After adding, what is remain, that you write simply. Then you will get Cr2O7 2 minus plus 14H plus 6Fe2 plus. It will give, right side you will get 2Cr3 plus 6Fe3 plus 7H2O. Okay, then this reaction is very, very important and always it is asked at examination. Now I am telling you other compound, important compound, potassium permanganate, KMnO4 compounds, or this is also compounds of transition elements, manganese, potassium permanganate, KMnO4. This is also very, very important compound. Okay, potassium dichromate, it is also used as oxidizing agent. Potassium permanganate is prepared by fusion of MnO2, manganese dioxide, with an alkali metal hydroxide and an oxidizing agent like potassium nitrate. Now how will you prepare potassium this permanganate KMnO4? Then for that 3 things are required. MnO2, second is metal oxide, metal hydroxide, and third is oxidizing agent, as for example potassium nitrate. This produces the dark green K2MnO4. This will produce a K2MnO4, only one Mn. Okay, K2MnO4, and its color is dark green. And this K2MnO4 disproportionates to give neutral or acidic solution. Okay, here K2MnO4, this will disproportionates in a neutral or acidic solution. Medium must be, when you want proportionation, then medium should be neutral or acidic. Neutral or acidic solution. Then it will give permanganate ion. Then reaction I am telling you, 2MnO2 plus 4KOH plus O2. Okay. Then here you will get two product you will get K2MnO4 plus 2H2O. Here O2 you are getting O2 functioning as oxidizing agent here, which you will get from KNO3 potassium nitrate. Then now reaction I am telling you, 2MnO2 plus 4KOH, that is a metal hydroxide, plus O2, it will give 2K2MnO4 plus 2H2O. Now you got K2MnO4, dipotassium manganese permanganate you can tell, or simply tell K2MnO4. Okay, dipotassium manganate. Then here you want actually permanganate. You want permanganate. Here is a MnO4. Then magnet is there, simple magnet. Then now this MnO4 you got. This MnO4 in the presence of acidic medium, it will give two product of manganese. One will be MnO4 1 minus, other you will get MnO2, and third product is 2H2O. In both reactions 2H2O is there. Then now balanced equation I am telling you, 3MnO4 2 plus 2 minus 3MnO4. Actually K2MnO4 was there, that here K2 are not writing, you are writing direct MnO4 2 minus. Then 3MnO4 2 minus plus 4H plus, it gives 3 product. Main product is 2MnO4 1 minus. This is actually KMnO4, potassium permanganate. Potassium you are not writing, only permanganate. MnO4 you are 1 minus you are writing. And in the beginning it was 2 minus K2MnO4. There MnO4 was having 2 negative, but here MnO4 is 1 negative. That's why it is permanganate. That was only manganate. Then 3MnO4 2 minus plus 4H plus, it gives 2MnO4 1 minus plus MnO2 plus 2H2O. Here we are getting two product of manganese. Then this is called disproportionate. Okay, disproportionation reaction also. Then disproportionation reaction means you are getting two product of the metal, means Mn you are getting two product, but both are differing in oxidation state. One is less oxidation state, other is more oxidation state. Then you can calculate very easily. Product is MnO4 1 minus. Then in this, if you will calculate, then you will get Mn is plus 7. MnO4 1 minus. Then O4 means minus 2 into 4 minus 8, and right hand side is equal to minus 1. Then if you will take it minus 8, you bring it to the right hand side, it's got plus 8 minus 1 means plus 7. Manganese is plus 7. And in MnO2 2 oxygen is minus 4, means Mn is plus 4. Then see, you got two product, one is Mn plus 7, other is Mn plus 4. Then this is called disproportionation reaction. Okay. Now further I am telling you, commercially it is prepared by alkaline oxidative fusion of MnO2 followed by the electrolytic oxidation of manganate 6. In a large scale, means commercially It is prepared by the alkaline oxidative fusion of manganese dioxide MnO2 followed by electrolytic oxidation of magnet 6. Reaction I am telling you, this MnO2, it is fused with KOH. MnO2 fused with KOH oxidized with air or potassium nitrate because it will give oxygen. Above reaction what I discussed, same way. Then MnO2 fused with KOH oxidized with air or potassium nitrate, then it will give MnO4 2 minus. MnO2 gives MnO4 2 minus in the presence of KOH and oxygen O2 or potassium nitrate, anyone, either O2 or air or potassium nitrate. Your purpose is to get oxygen, either you use air or use potassium nitrate, you will get oxygen. Then MnO2 plus KOH plus oxygen, it gives MnO4 2 minus, that is a magnet ion. Now this magnet ion on electrolysis, on electrolytic oxidation in alkaline solution, here oxidation you are doing in alkaline solution, then MnO4 2 minus means magnet ion, it gives permanganate ion, means MnO4 1 minus. MnO4 1 minus. This is called permanganate ion. Okay. In the laboratory, a manganese second. In a lab, I am talking about. In laboratory, a manganese second ion salt is oxidized by peroxo disulfate to permanganate. In laboratory, how will you get permanganate, potassium permanganate? Then for that I am telling you that a manganese ion salt is oxidized. Then manganese ion salt means you can write 2Mn2 plus. Mn2 plus is then salt, cation. Then 2Mn2 plus peroxo disulfate. Peroxo disulfate means H2OH 2 minus. This is called disulfate. Peroxo disulfate H2OH 2 minus and plus H2O. It gives 3 product. First product is MnO4 1 minus means permanganate. Other product will be sulfate ion SO4 2 minus plus hydrogen ion you will get. Balanced equation I am telling you 2Mn 2 plus 2Mn2 plus 5H2O8 2 minus plus 8H2O. 3 reactants you are using 2Mn2 plus 5H2O8 2 minus plus 8H2O. You will get 2MnO4 1 minus, that is the permanganate main product, plus 10SO4 2 minus plus 16H plus. Okay, but here you can see hydrogen is there, sulfate ion is there, then obviously it will give H2SO4. Directly you can write H2SO4 also. It will give finally sulfuric acid. Then potassium permanganate. Potassium permanganate forms a dark purple, almost black you can tell. Potassium permanganate forms a dark purple crystal, purple. It looks like a black, almost black crystals, which are isostructure with those of KClO4. Its structure will match with KClO4. KClO4 and KMnO4 structure is similar. The salt is not very soluble in water. very less soluble. You remember, in lab you will use potassium permanganate. It will not dissolve so quickly and it is very less soluble. 6.4 gram per 100 gram of water at 293 Kelvin. Means at a normal temperature it will dissolve per 100 gram of water only 6.4 gram. 6.4 gram potassium permanganate will dissolve per 100 gram of water. If you take extra more, then it will settle down. Okay. Then this you remember, its solubility is less, and at a normal temperature means 293 Kelvin per 100 gram of water only 6.4 gram potassium permanganate dissolves. But when heated, it decomposes at 513 Kelvin, means 2 KMnO4. It gives K2MnO4 plus MnO2 plus O2. On heating it will decompose, 2 KMnO4 will decompose. It will give K2MnO4 plus MnO2 plus O2. Okay. And now I am telling about the properties, physical properties. It has two physical properties of considerable interest. First, I am telling you, its intense color and its weak temperature dependent paramagnetism. This is the first physical property. Intense color and its weak temperature dependent paramagnetism. Means if you will change the temperature, paramagnetic properties will change. This can be explained by the use of molecular or vital theory. Okay. Now, the magnet and permanganate ions are tetrahedral. Its structure is tetrahedral. Actually, physical properties I told you. First, its color is intense color. Intense, what type of color? Purple color. And properties, this paramagnetic properties, they are paramagnetic but temperature dependent. And now I am telling you that magnet and permanganate. Magnet MnO4 1, MnO4 2 minus. MnO4 2 minus is called permanganate, magnet. MnO4 2 minus is called magnet, and MnO4 1 minus is called permanganate. Then now magnet and permanganate ions are tetrahedral. Tetrahedral, just like chromate and dichromate, same way. Then here tetrahedral magnet structure you can write very easily. 4 oxygens are there. Then 2 oxygen is a single bond. 2 oxygen are making single bond with manganese. Manganese in the middle. And 2 oxygens are making double bond. Correct? 2 oxygens are making single bond, but one electron they have. Each electron single bond oxygen, they have one electron, and other 2 oxygen which are making double bond. Then this is called tetrahedral magnet ion. Its color is green. Remember, what is the difference between the magnet and permanganate? Then magnet is of green color, green ion, and permanganate is purple ion. Question is asked. Then tetrahedral structure of magnet, I told you that 4 oxygens are there. Then 2 oxygens are making single bond with Mn and have one electron, and other 2 electrons are making double bond. This is actually tetrahedral magnet. And now tetrahedral permanganate, its structure is again same way. Here 3 oxygen atoms are making double bond. 3 oxygen, Mn is in the middle. 3 oxygens are making double bond. Then 6 electron is freezed. Now fourth one is making bond with oxygen, that is a single bond, and have one electron. Then 3 electrons have a double bond, and one oxygen has single bond, and one electron is there on oxygen. Okay. Then this is a tetrahedral permanganate. Its color is purple. Now again other properties I am telling you. The green magnet is paramagnetic. Other different I am telling you how will you differentiate magnet and permagnet. Then the green magnet means you are talking about magnet, that is the green. The green magnet is paramagnetic with one unpaired electron. Green magnet is paramagnetic with one unpaired electron, but the permagnet is diamagnetic. Okay, here in magnet, if you will see the structure, electronic configuration, then one electron is unpaired. That's why it is paramagnetic. But the permagnet is diamagnetic. No unpaired electron is there. Okay. Now another property is the pi bonding. The pi bonding takes place by overlap of p orbitals of oxygen and d orbitals of manganese. It forms pi bonding. Then in pi bonding, p orbitals of oxygen and d orbitals of manganese takes part. Now other reaction I am telling you, chemical reaction. Acidified permanganate solution. Acidified permanganate solution oxidizes oxalate to carbon dioxide. Oxidizes means more oxygen it will give. Very simple way. Acidified permanganate solution oxidizes oxalate to carbon dioxide. And you can compare always when oxidation is going on, then you will find oxidation states are changing. Okay, means they will lose electron. Okay, it will lose electron. Means plus sign will increase. Other side it will plus sign will increase. Other side it will decrease. Same things. Okay. If you will compare, then you will find left side, that is it is more oxidation, this less oxidation state. Now other side it will increase, means it lost the electron. That's why plus charge increased. Then oxalate ion, you can write very simply COO2, COO2, or you can write carbon single bond, and each carbon has 2 oxygen, and 1 negative charge is there in both oxygen. COO, both carbons are joined by a single bond, and both oxygen COO, last oxygen 1 electron, and down COO, last oxygen single electron. This charge is there, negative charge. Both have 1 negative charge. Then it will convert to carbon dioxide. It convert to CO2, and it will release 10 electron. Means 5 COO whole 2. 5 COO whole 2. It gives 10 CO2 plus 10 electron. Correct? This is the half reaction. This is the reduction reaction. Okay. But this reaction will take place in acidified permanganate solution. Actually, only this, due to acidified permanganate solution, this carbon, if you will compare, then you will find that oxidation is going on. Okay. Then I told you carbon to carbon dioxide, means oxalate to carbon dioxide, iron second to iron third, and third is nitrites to nitrate. Okay. Then first reaction I told you 5 COO whole 2, it gives 10 CO2 plus 10 electron, and same way 5 Fe2 plus, it will give 5 Fe3 plus 5 electron. Now third reaction 5NO2 means nitrate plus 5H2O, it gives 5NO3 means nitrate plus 10H plus 10 electron. This is now electron. Here all three reactions are in the right hand side. Right hand side means it is liberating, it is giving. Okay. Then here all three means because now all are giving distance, electron, releasing electron. Then releasing electron means oxidation reaction. Then all three are oxidation reaction. Okay. Now full reaction, how will you write? The same way. Oxidation reaction plus half oxidation reaction plus half reduction reaction. If you will add, then electron will be cancelled out, and what you will get, that is the final reaction. If we represent the reduction of permanganate, if we represent the reduction of permanganate to magnate, manganese dioxide and manganese second salt by half reaction, I am telling you reduction reaction, and then you can add MnO4 plus 1 electron, MnO4 1 minus plus 1 electron. Now the reduction, because it is absorbing the electron, it is gaining the electron, then you will get MnO4 2 minus, and that time during the reduction process potential developed is 0.56 volt. Second reduction reaction, MnO4 plus 4H plus 3 electron, this is also reduction, plus 3 electron adding, you will get MnO2 plus 2H2O. In this process reduction potential value is plus 1.69 volt, more than first one. First one was 0.56, now it is 1.69 volt. Third reaction is MnO4, all are with MnO4, remember. Now third one MnO4 plus 8H plus 5 electron, this is also reduction, plus 5 electron, it is giving Mn2 plus 4H2O. Now it is producing how much potential? Then it is plus 1.52 volt, E is plus 1.52 volt, little less than second one. If we can see the reaction, then what we will find? The hydrogen ion concentration of the solution plays an important part in influencing the reaction. First reaction, no water was there, you have not used this hydrogen ion, you have not used, but in second and third you have used hydrogen ion, means acidic medium. In second case 4H was there, in third case 8H was there, and where H is there, then product obviously it will form water molecules. Then hydrogen ion concentration plays a big role plays an important part in influencing the reaction. Although many reactions can be understood by consideration of redox potential, kinetics of the reaction is also an important factor. Per magnet, per magnet at hydrogen ion concentration is equal to 1 means normal. H plus is equal to 1. H plus is equal to 1. This is the condition I am telling you. Per magnet at H ion concentration is equal to 1 should oxidize water. Should oxidize water. But in practice, the reaction is extremely slow. Rate of reaction is slow unless either manganese second are present or the temperature is raised. If manganese second is present, the reaction rate will be high or temperature should be more. Now other reaction I am telling you in acidic reaction, that is important reaction of KMnO4. Then iodine is liberated from potassium iodide. This permanganate it will function as oxidizing agent. Then iodine is liberated from potassium iodide, means you can write 10 iodide ion minus 10 I1 minus plus 2MnO4 1 minus plus 16H plus acidic medium 16H plus. It gives 2Mn2 plus H2 8H2O plus 5I2 means iodide ion I1 minus converted to iodine I2. 1 electron lost. Minus I minus 1 now became I2 0. Oxidation state 0. Second reaction with ferrous, you see, ferrous will convert to ferric. Ferrous is green color and ferric is yellow color. Okay, don't forget. Then 5Fe2 plus MnO4 plus 8H. This also reaction takes place in acidic medium 8H plus. Then 5Fe2 plus MnO4 means you are talking about KMnO4. You are adding ionic reaction MnO4 1 minus. 5Fe2 plus MnO4 1 minus plus 8H plus. It gives Mn2 plus 4H2O plus 5Fe3 plus. Ferrous converted to ferric plus Fe plus 2 now became Fe plus 3 means loss of electron. And other reaction I am telling you, oxalate ion or oxalic acid is oxidized. Temperature requirement is 333 Kelvin. Already I discussed this reaction. 5C2O4 plus 2MnO4 1 minus plus 16H. Actually all reactions are important, keep in mind. 5C2O4 means oxalate plus 2MnO4 1 minus means you are talking about KMnO4, but ionic reaction you are writing 5C2O4 2 minus plus 2MnO4 1 minus plus 16H. It gives 3 product 2Mn2 plus 8H2O plus 10CO2. Now other reaction, sulfide reaction. Hydrogen sulfide is oxidized, sulfur being precipitated. Already this type of reaction I told you. Here again I am repeating. H2S is converting to S2 minus. H2S is giving in presence of KMnO4. H2S is converting to 2H plus S2 minus. Then here now you can see H2S. Then S was minus 2, H2S oxidation state. S was minus 2. Then H2S will break into 2H plus H2 minus, and this H2 minus main reaction is H2 minus plus KMnO4 plus acid medium. It gives 2Mn 2 plus H2O plus 5S. Then I am telling you now balanced equation. 5S2 minus plus 2MnO4 1 minus plus 16 hydrogen H plus 16H plus. It gives three product 2Mn 2 plus H2O plus 5S. Actually sulfur will be precipitated. Now next reaction, sulfurous acid or sulfite SO3 is oxidized to sulfate or sulfuric acid. This reaction is also very important. 5SO3, I am talking about sulfite, 5SO3 2 minus plus 2MnO4 1 minus means potassium permanganate plus 6H plus. It gives three product 2Mn 2 plus. Everywhere you are getting 2Mn 2 plus 3H2O. Water is also getting everywhere plus 5SO4 2 minus. Only you are differing in the this product of sulfur. Okay, in one case you got carbon dioxide, other you got sulfur, and in this case sulfate. These are the main change. And next reaction, nitrite is oxidized to nitrate. Nitrite means 5NO2 1 minus plus 2MnO4 1 minus plus 6H plus. Means these reactions are taking place, all reactions are taking place in the presence of acid medium and potassium permanganate. Okay, then nitrite 5NO2 1 minus plus 2MnO4 1 minus plus 6H plus. It is again giving two product 2Mn 2 plus. It is common in every reaction. And now nitrate 5NO2 is converting into 5NO3 1 minus plus 3H2O. These reactions I have told you all are very important reaction. This reaction takes place in acid medium. Now some reaction which takes place in neutral or faintly alkaline, less alkaline. Neutral or faintly alkaline solution. In that also some reaction takes place. That reaction is also important. Question is asked many times. Question has been asked, acidic medium or neutral medium. Hence you should differentiate or you should keep in mind the condition. Then first reaction I am telling you, a notable reaction is the oxidation of iodide to iodate. Iodide to iodate. Iodate, DATE. Okay. Then 2MnO4 1 minus plus H2O plus I1 minus. Then you will get three product 2MnO2 plus 2OH minus plus IO3 1 minus. This is the iodate. This you remember that 2MnO4 1 minus plus H2O, because it is reaction is neutral, that's why H2O you have used, plus iodide ion I1 minus. It gives 2MnO2 plus 2OH 1 minus. OH 1 minus is basic. Okay, then neutral is giving basic, no problem, plus IO3 1 minus. This is the main product. Now other reaction, thiosulfate is oxidized almost quantitatively to sulfate ion. Means in quantitative determination this reaction is used. Then thiosulfate is oxidized to sulfate. Then thiosulfate is a what? H2O3 2 minus, that is the thiosulfate. Sodium thiosulfate Na2 H2O3. Then here ionic reaction you are writing. Then here reaction will be 8MnO4 1 minus plus 3H2O3 2 minus thiosulfate ion plus H2O, because reaction is neutral. It gives 3 product 8MnO2 plus 6SO4 2 minus sulfate ion plus 2OH minus. Here also you are getting OH. Here also in both reaction you are getting MnO2. Now third reaction I am telling you, manganese salt is oxidized to MnO2 in the presence of zinc sulfate. Zn sulfate is required here, or zinc oxide is used as a catalyst. Zinc sulfate or zinc oxide is used here as catalyst. Okay, and actually this is the oxidation process. Then zinc sulfate or zinc oxide catalyzes the oxidation. Then here what is the reaction? Then manganese salt. Then manganese salt means Mn must be there, cation, Mn2 plus cation, and KMnO4 is already required. And for catalysis you are using either ZnO or ZnSO4, any one. Then reaction I am telling you, 2MnO4 1 minus plus 3Mn2 plus, that is the manganese salt, plus 2H2O. It gives 2 product 5MnO2 plus 4H plus. This reaction is very, very important. Again I am telling you that 2MnO4 1 minus plus 3Mn2 plus 2H2O, it gives 5MnO2 plus 4H plus. Okay. Here you should remember, permanganate titration in presence of hydrochloric acid are unsatisfactory. Permanganate titration in presence of HCl acid are unsatisfactory. Why? Since hydrochloric acid is oxidized to chlorine. Question is asked. That's why HCl is not used. Now come to the uses of permanganate. Besides its use in analytical chemistry, potassium permanganate is used as a favorite oxidant in preparative organic chemistry. Its uses for the bleaching of wool, cotton, silk and other textiles fibers, and for the decoloration of oils are also dependent on its strong oxidizing power. Then here it is used as bleaching of wool, bleaching agent for wool, for cotton, for silk and other textiles fibers. Okay, and also as a decolorization agent of oils. Decolorization of agent for oils, it is used, and these properties are dependent on strong oxidizing power of KMnO4. Okay. Now I am stopping only here. Next class I will discuss F block elements. Thank you.